Hi, I'm going to try to explain the idea of the limit in mathematics, which is the basis for the calculus. So, uh, as a start, I must say that the idea of a limit is the most fundamental and the most creative idea that happened in mathematics, and it is a concept of hard to grasp. So it needs high attention and high focus in order to grasp the main intuition about it and understand the real definition of it. So let's start by taking this Cartesian, for the line, this Cartesian coordinate and draw this straight line as like this. So if I want to calculate the slope of a line, I'm going to say, so let's suppose that this y, this x, I'm going to say that it is the change of y over the change of x. We have another definition for it. We say it is the rise over the run. Okay, so this means that it is equals to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, so suppose also we have this Cartesian coordinate, but this time the function take a parabolic form like this, and suppose that f of x equals x to the power of 2 or the x squared. As you see in this function, the graph of this function is curved. But what means to have a curved graph? A curved graph means the change between any points is instantaneous change. So if I want to calculate the limit at this point, how to calculate it? We have for really centuries until the came of Newton and Leibniz, we couldn't calculate this form of change of rate, okay, or the slope at that point, because it is always lead us to a division by zero, and division by zero means it is undefined. And all of mathematics is about the real definition, or about taking the real quantity of the world in order to use it, as we will see in the mechanics. So here comes the idea that really came from the origin. I mean its origin came from the Greeks, from Archimedes. I don't know if this spelling is right, but Archimedes thought about it, but not in the form of the function. The Greeks was very, very, very good at taking the area of the the mathematical areas of the shapes, which is the regular shapes. The regular shape like the square, the rectangle, and the others that fall in the same category like the triangle. But what about the circle? Oh, this is not a circle, but we suppose this is a circle. What about the circle? The circle equals to the idea of the curved function. Why? If we take this part only of it, we have this curve which is similar, so we have this point and this point and this point and so on. So one of the main ideas of the Archimedes that if we try to divide by this secant line the circle and get smaller secant line as we can. So let's try to draw another circle, but this time we will take from it, like here, the secant line passed through those 2 points. So this is a more accurate definition for the, or let's say this is more accurate representation of the distance between the two points. So the idea will flow. If we take the smallest distance between the 2 points, this will allow us to take the real distance between them. So if we return to the idea of the curve here, so the main idea flows from the secant line and the tangent line. Tangent line because it touches at 90 degree the curve. It's like this. This is the tangent line. Oh, this is wrong. This is not the tangent line. Sorry. So tangent line will be like this. Okay, suppose so. This is here is the point and the tangent line, and this is the secant line. So the secant line, I can calculate the slope of the secant line. Secant line slope m sub s equals, just like the regular, as we say in the linear function, delta y over the delta x. So the idea of a limit is that if we try to make the secant line, the 2 points of the secant line, as small as possible, taking the smallest distance between them, so it can be really negligible, okay, then the limit of the secant line, or the slope of the secant line, will equal the slope of the tangent line. Okay, so taking it small, if I will fix this point, and let's say it's P, and move Q to here, we will see that the secant line become more similar to the tangent line, taking it more close until the distance nearly equal to the 0 or 0, it will equal the slope of the secant line will equal the slope of the tangent line. So the main idea flows from the equation. We call it the quotient equation. So the f of x prime, which is the slope of the tangent line, equals the limit of, say, h, as h approaches 0. H is the difference between x sub 1 and x sub 2, and okay, let's say that is x, and this is x plus h, and here is the f of x, and here f of x plus h. So f of x plus h minus f of x divided by x plus h minus x. So x cancel from the from the below, and we will have limit of h approaches 0. To just as a reminder, h is the difference between the 2 points. So f of x plus h minus f of x divided by h. So let's take the f of x as the x squared, as in the case above. So limit of h approaches 0. X is going to be x plus h squared minus x squared divided by h. So we will not try the limit. X squared plus 2xh minus plus h2 minus x squared divided by h. So x cancel the x squared cancelled with the x squared, and we will have the limit of h approaches 0, h 2x times h plus h squared. If we take the h as a common factor, so this is going to be x plus h divided by h. The h cancel, and I am now allowed to take or I can take the limit. So as the limit of 2x plus h as h approaches 0, so at that limit I will have 2x because h equals to the 0, and this is the derivative of the x to the power of 2 or the squared function. I hope you understand, and thank you.